Hi everyone, for today's lesson we are going to learn about the rational zero theorem. Our learning objectives for today are for you to be able to say, I can use the rational zero theorem to identify all possible rational zeros of a polynomial function. And I can use my graphing calculator to identify a rational zero to help me solve polynomial equations. The graphing calculator part we are not going to be doing in this lesson today, just based on where we are at in the school year. So this is something that we are going to be using later on in the school year, or later on in other lessons. So what if we don't know a zero or a factor of a polynomial function? So what if we don't know? All the way up until this point, I have said, here's a polynomial function. Divide by x plus 1 or divide by x squared plus, 2x minus 7. I've given you a zero saying this is the number that you're going to use for synthetic division. Or I've given you x plus 2 and I've said, hey, use synthetic division to factor the polynomials. But what do you do when you don't have that information? Where would you start looking for possible zeros? That's where the rational zero theorem comes in. The rational zero theorem says that if you have a polynomial that has integer coefficients, that means that all of the coefficients are positive and negative whole numbers, then every possible rational zero has the form of P over Q. And what P represents are all of the factors of the constant term divided by the factors of the leading coefficient. So it's the factors of your constant term, which your constant term is the last number of your polynomial. It's the term that does not have an x next to it. And your leading coefficient, that is your number that's in front of the variable with the highest degree. So what you do with using the rational zero theorem is you're going to list all of the numbers that are factors of that constant term, starting with the number 1 and going on until you have all of the factors listed. And when you list them, you're going to use a plus or minus. And all of this is going to be is just a list of values that could be a rational zero. Now the word rational means that we're talking about an integer or any number that can be written as a fraction of integers, like an integer over an integer. Those are considered rational numbers. And those rational numbers are not that every single polynomial has a rational zero, but if you wanted to try a set of rational zeros to help you divide or factor a polynomial, you can use this theorem. Now, when you have your fraction of your factors of your constant term divided by the factors of your leading coefficient, you have to divide every numerator by every denominator. So you have to divide. There's going to be a lot of factors up top and a lot of factors below, and every factor will be divided by every factor. So every factor in the numerator will be divided by every factor in the denominator. So looking at letter A, they are asking us to list the possible rational zeros. Possible rational zeros we write as shorthand PRZ. PRZs are your possible rational zeros. So we want to list the possible rational zeros of our function using the rational zero theorem, making sure that we simplify. So I am going to start off with my p-value. My p-values are going to represent all of the factors of 8. And all of the factors of 8 they are plus or minus 1, plus or minus 2, plus or minus 4, and plus or minus 8. Then my Q represents all of the factors of my leading coefficient, and my leading coefficient is the number 2. So we're going to write down all of the factors of 2, and they are plus or minus 1 and plus or minus 2. The reason why we use plus or minus is because these are factors, and we know that whenever we are factoring using parentheses, we could have a plus sign in our parentheses, we could have a minus sign, and so therefore factors could be positive or negative. So when I write out P over Q, that's going to be all of my factors of 8, plus or minus 1, plus or minus 2, plus or minus 4, and plus or minus 8, divided by all of the factors of 2, plus or minus 1, and plus or minus 2. We are going to, once again, divide every numerator by every denominator. So I'm going to go 1 over 1, which is plus or minus 1. 1 over 2, which is plus or minus 1/2. 2 over 1, which is plus or minus 2. 2 over 2 is 1. I already have 1 written down. I'm not going to write it again. 4 over 1, which is plus or minus 4. 4 over 2, which is plus or minus 2, and I already have that written down, so I'm not going to write it down again. Plus or minus 8 over 1 is plus or minus 8, and 8 over 2 is 4, and I already have that written down. All of these values represent possible zeros of this function. It doesn't mean that they actually are, it just represents a list of possibilities. For letter B, my p-value is all of the factors of 6. And the factors of 6 are plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. Q represents all of the factors of my leading coefficient, and in this case, it's an invisible number 1. And that is simply plus or minus 1. So I am going to write P over Q, and so that's going to be plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, all over plus or minus 1. So now I'm going to divide every numerator by every denominator. 1 over 1 is plus or minus 1, 2 over 1 is plus or minus 2, 3 over 1 is plus or minus 3, and 6 over 1 is plus or minus 6. Now, whenever your leading coefficient is 1, you really do not need to show this fractional work because, you're just going to end up with the factors of your constant term anyways. So all you need to do is simply list the factors of your constant term and you're good to go. This is only true if your leading coefficient is 1 or a negative 1. Now, once again, these values, they are possible zeros. Doesn't mean that they are guaranteed, so they aren't guaranteed to be zeros. It's just this is your list of possibilities. So how could we find which, if any, are actual zeros? So since this is your list of values that could possibly work, what you'll have to do is you'll have to synthetically divide every factor until you get a remainder of 0. Once you get a remainder of 0, then you know that factor actually worked. And then therefore you can follow the same steps that we did in our previous lessons where you would continue with factoring and then find the remaining zeros. Now, example number 2, we have cubic functions. And our cubic functions, we want to find all of the real zeros of the function. Now, for all of these problems, because they're cubic and they will have 4 terms, try to factor first, if you can. If factoring doesn't work, then you'll have to use the possible rational zeros to identify your rational zeros, your reasonable rational zeros. These are the ones that actually work. The RRZs are the ones that actually end up working out. So looking at letter A, the first thing I'm going to do is I'm going to try to factor. There are 4 terms, and I know that whenever you see 4 terms, you have to do factoring by grouping. So I'm going to put parentheses around the first 2 terms, plus negative parentheses around the last 2 terms, and I'm just doing it lightly so that I can see what ends up happening. X squared, or x to the third minus 4x squared, have in common an x squared with my leftovers being x minus 4. Plus, negative 15 and 18 have in common a negative 3 with my leftovers being 5x minus 6. These 2 parentheses, my insiders, are not the same. And so because they are not the same, this tells me that factoring doesn't work. And now I'll have no choice but to work with the possible rational zeros and synthetic division. So I need to identify my possible rational zeros, PRZs, and they are going to be, well, what's nice is that my leading coefficient is 1, so I just need to list all of my factors of 18. That is plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, plus or minus 9, and plus or minus 18. So if you ever wanted to make sure that you are listing all of the possibles, match them up. I know 1 would be matched with 18, 2 would match with 9, and 3 would match with 6. So now I need to start at the very beginning. Always start with positive 1. Start with the easier numbers. Don't work with the fractions right away. You want to work with, or like a number 18. Instead, start logically with the number 1. And we're going to do a quick, small synthetic division. I'm going to write 1, negative 4, negative 15, and 18. Bringing down the 1, 1 times 1 is 1. Negative 4 plus 1 is negative 3. 1 times negative 3 is negative 3. Negative 15 plus negative 3 is negative 18. 1 times negative 18 is negative 18. And we end up with the remainder of 0. We were very, very lucky for this problem. The very first number that we tried worked. So what happens next? Well, this 1, because we know it's a factor, we're going to rewrite it as an x minus 1 because we know that it comes from, the x equals 1 would come from a parentheses of x minus 1, the opposite of what we see. And now I'm going to rewrite what's below the line as x squared minus 3x minus 18. Now they're asking us to find the real zeros, all real zeros, so that means I need to make this equal 0. I'm going to rewrite x minus 1, and then I'm going to split this apart into 2 parentheses, splitting the x squared apart into an x, and asking myself what 2 numbers multiply together to equal negative 18, but together add to equal negative 3. And that is a negative 6 and a positive 3. So all of my zeros are going to be the opposite of what I see on the inside, and that's x equals 1, 6, and negative 3. And those are all of my zeros. Now, if this quadratic didn't work, we'd have to use the quadratic formula. And then that's how we would find our remaining zeros. Let's go ahead and look at letter B. For letter B, we always try factoring first. So I'm going to put parentheses around the first 2 terms and parentheses around the last 2 terms. X to the third minus 5x squared have in common an x squared. My leftovers is an x minus 5. Plus 7 and 35 have in common a 7. Leftovers is x minus 5. Because both of my parentheses are the same, this means that it is factorable by grouping. So I'm going to go back to the beginning and write 0 equals and do this factoring for real. I will have x squared times x minus 5 plus 7 times x minus 5. And now I'm going to rewrite 2 parentheses, one with my outsiders, which is x squared plus 7, and one with my insider, which is x minus 5. Now, a lot of kids like to write 2 parentheses to represent their insiders. We only need 1. So 1 parenthesis for the outsiders, 1 parenthesis for the insiders. So from here, we need to set each piece containing a variable equal to 0. So far I know that I'm going to get x equals 5, but we are interested in all of the real zeros. So let me see what happens with this x squared plus 7. I'm going to write x squared plus 7 is equal to 0. I'm going to subtract 7 on both sides, and I end up with x squared is equal to negative 7. I'm going to take the square root of both sides, and I end up with x equals plus or minus I square roots of 7. Now, I makes this imaginary, so therefore that is not a real answer, and my only real answer is x equals 5. This work, I need to see it. And the reason why I need to see this work is it shows me your thinking and that you took this concept to the next level to make a decision about which zeros were real and which zeros were not real. The next problem is a solo question, but I want to go ahead and show you how to do this solo question. So for this solo question, the first thing that we need to do is we need to check our check factoring. So I'm going to put parentheses around the first two terms and parentheses around the last two terms. The first two terms have in common an x squared, leftovers is an x minus 8. And these two terms have in common a 1, but the leftovers is a 5x plus 14. My parentheses are not the same. So because my parentheses are not the same, that tells me that it's not factorable by grouping. So that means I need to identify my possible rational zeros. That's going to be my first step. And what's really nice is that my leading coefficient is 1 this time, so I'm only going to write down the possible, the factors of 14. So that is plus or minus 1, plus or minus 2, plus or minus 7, and plus or minus 14. From here, I'm going to start with 1. Always start with 1. I'm going to be looking for that. Did you start logically with the number 1? And I'm going to try to do synthetic division. So I'm going to put 1 in the box, and I'm going to write 1, negative 8, 5, and 14. And I don't need to make it super big because I might end up doing synthetic division a lot. So I want to make sure I have space for other work. So I'm going to bring down the number 1. 1 times 1 is 1. Negative 8 plus 1 is negative 7. 1 times negative 7 is negative 7. I can see that this is not going to work out. I end up with a 12, and I need a 0, so 1 does not work. So let's go ahead and try negative 1. So I'm going to write 1, negative 8, 5, and 14. I'm going to bring down the number 1. Negative 1 times 1 is negative 1. Negative 8 plus negative 1 is negative 9. Negative 1 times negative 9 is 9. 5 plus 9 is 14. Negative 1 times 14 is negative 14. And boom, there's my 0. So that means that negative 1 is going to be one of my zeros that I already know. So that negative 1 comes from the parentheses x plus 1 of the opposite of what I see inside. And the 1, negative 9, and 14 comes from the parentheses x squared minus 9x plus 14. So it creates that parentheses. And this is going to equal 0. So now I need to factor further x plus 1, and I'm going to split this apart into two parentheses and ask myself, what two numbers multiply together to equal positive 14 and together add to equal negative 9? That is a negative 7 and a negative 2. So my solutions are negative 1, 7, and 2, and you will list all of them because these are all of the zeros that end up working. Now, once again, if this quadratic is not factorable, you might have to use the quadratic formula. I am going to skip for this year the quartic functions. This is something that I will have to teach at another time. But in the meantime, if you have any questions over anything I taught you over reasonable rational zeros, possible rational zeros, and the rational zero theorem, please make sure that you let me know as soon as possible. Otherwise, I hope you have a wonderful day.